So yeah, building AI apps with Java and Cosmos DB. A few assumptions that I've made. You're a Java developer, a pretty good assumption if you join this session. You have little experience or maybe zero experience building AI apps, and maybe you want a crash course and you've not used Cosmos DB, but you're open to it. So if all of those things are true, hopefully you get a lot out of this session. Even if none of them are true, I saw the session before. There's quite a lot of stuff there. If all of that was familiar to you, then maybe this is going back to basics, but hopefully you'll still get something out of the session. So what skills does one need to build AI apps? Well, I'm sorry to tell you, you need proficiency in Python programming. You also need to be a machine learning expert, preferably with a PhD and published, 5, 6, 7 papers in scientific journals. And of course, you want skills in data processing and data management. Of course, this is not completely true. Although our central Java team here at Microsoft did some research recently, and apparently 90% of Java developers that they interviewed thought that this was true. So I just wanted to bust that myth straight away. Of course, skills in data processing and data management is pretty much useful for building any app. So you pretty much need the same skills that you need for building any app to build an AI app, in my opinion. Of course, there's some new concepts to learn, but you don't need to be a Python expert. You don't need to be a machine learning expert. Of course, there are frameworks in Java, some very good frameworks, not least of which is Spring AI. It may help for me to define what I mean by AI apps. Of course, I'm talking about applications that use large language models. That's the state of the art. This obviously is a very disruptive technology, as everybody knows, and we're going to be looking at GPTs here for an OpenAI deployed in Azure OpenAI. Of course, there's lots of different derivatives, as everybody has heard of by now, but that's what I'm going to choose for this session. So why Azure Cosmos DB for AI apps? Cosmos DB may not be something that you're very familiar with. Warning, a little bit of a sales pitch here. The biggest reason, the most facile reason I can give, of course, is that ChatGPT uses Cosmos DB to scale and to store its chat data. So I suppose I could say if it's good enough for OpenAI, maybe it's good enough for you. Also, the largest Azure Cosmos DB workloads, if you're developing in Java, run on Java. So it's heavily used by Java customers, and the Java SDK for Cosmos DB is very battle tested. So if you are a Java developer building in Azure or thinking about building in Azure, Cosmos DB would be a pretty good place to go, especially if you're building scalable enterprise applications and you're building AI apps as well. A few less hand-wavy reasons for choosing Cosmos DB for AI apps. Of course, it's general purpose. It's very cost-effective. It has guaranteed SLA-backed low latency. It's still the only database service in the world, as far as I'm aware, that provides this. It's schemaless for flexibility. In the world of LLMs, this is going to be very important because, of course, LLMs are much better at interpolating changes to schema dynamically than traditional application architectures and contexts and so on. So schemaless databases are going to be winning there. Cosmos DB allows you to keep transactions and vectors stored together. Vectors are what's used for retrieval augmented generation, which you heard about in the previous session if you were there. If not, I'll explain it and go back to basics, as I said. And in a lot of cases, vector stores are only being used as vector stores, but in Cosmos DB, you can use it as a transactional store and a vector store at the same time in the same place, which is very useful in a number of scenarios. And of course, it has some of the features that you would expect, full text search, hybrid search, and more features coming along. And of course, it's highly scalable and so on. That's enough of the sales pitch for Cosmos DB. Let's get back to AI and building AI apps with LLMs in Java and Spring AI. There's a lot of patterns. You heard about some of them there. You heard about LangChain for J earlier, and some of the patterns were covered. If you're a beginner, if you're coming at this new and this is kind of making your head spin, I think the easiest way to get into the patterns and why and what they mean is to just understand why they're important. And by the time I've gotten through this, it will seem very obvious, but sometimes it's helpful to bring obvious things from the back of your mind to the front of your mind. And I'm going to do this in a kind of fun way, using a fun analogy and opening with a slightly controversial quote. LLMs perform diffused information retrieval given a prompt. They are basically databases, indeed, a new form of database. That was something that Tim Scarf, a former colleague, used to work at Microsoft over here, and has since then gone on to found Machine Learning Street Talk, which is the #1 most subscribed YouTube channel for machine learning, believe it or not. And he came out with this on social media somewhere, and I happened to catch it. Pretty controversial statement. It doesn't really matter whether you believe that's true or whether you agree that it's true. It kind of helps in this analogy. And if we run with that analogy and we just compare the old and new quote unquote databases, traditional databases, of course, if you want to get anything out of them, you need to use a highly structured and rigid query language as inputs, some SQL or some derivative of SQL. And you get 100% accurate and deterministic outputs. With the LLM, the new quote unquote database, of course, inputs queries are highly flexible. Indeed, human language, you can just type in anything that you want in there. And what you get, although it's not 100% accurate and deterministic, as many who've tried ChatGPT and things like it have seen, it's often very close. And this can be fine-tuned in order to get the responses you want. And most of the game that we're playing here with all of these patterns is really about fine-tuning of output accuracy and predictability. And that's one of the primary goals of all the emergent patterns, pretty much. Not the only goal, but it's really at the forefront. And so it's the trade-off really between input flexibility that you get, which is obviously very impressive, versus output accuracy and predictability. And what this ends up translating to day to day as you're building these experiences is how much code you write versus letting the LLM do all of the work, which I know can be a scary concept if you're a developer, letting AI just do everything. But I'm sure you must have thought this, and I definitely have in the past, and certainly when I was first looking at these things. Why don't I just put the URL to ChatGPT in an iframe and just change the title and let it do its thing? And will it do enough? And to be honest, in a lot of cases, a lot of apps out there, they're not actually doing much more than that. They're just consuming OpenAI's API layer and adding some prompts that are specific to a certain scenario. And the LLM is doing most of everything else in that case. And that can work in some scenarios, but in other scenarios, it won't. And all of these patterns are about balancing the trade-off when you need things to be more accurate, more appropriate, more predictable, and so on. So with that in mind, it should be easy then, without me explaining all of the patterns, to understand what they're driving at. I've just called out 5 of the top most popular patterns that are talked about and used often today. Tool use function calling. You saw an example of it before there in the LangChain session. This is where the framework is going to tell the LLM to generate code in real time that is able to dynamically call a function that you have defined up front. So the goal here is you define a function, you know its behavior, it expects certain parameters. As long as the LLM can pass those parameters to your function, you know what to expect from the function. In other words, it's deterministic. The behavior is known and accurate. And so again, it's the same with all of these patterns. That's what you're trying to do in that case. Retrieval augmented generation, what I like to call spoon feeding the LLM. If you ask a question of an LLM, you'll obviously get a response that's based on its own internal training data set, which is vast. The more data that is being scanned and scoured internally, the higher the probability that you'll give you the wrong answer, obviously. So if you direct it more pointedly to some data that bears a close relationship between the question that you're asking, of course, it's going to be more likely to be accurate. Again, same thing. We're trying to balance deterministic behavior and accuracy versus more creativity and let's say more random behavior that you might get out of the box with the LLM. Context augmented generation, or CAG. We do like creating complicated acronyms, don't we, for things that should be simple. So also known as chat memory. So most implementations are doing this now, storing the responses and the chats that were previous, and then feeding that into the context of the LLM. So again, it's giving you a more appropriate accurate response. Multi-agent systems is probably bears a little bit more talking about, also known as agent specialization. The more prompts you give to an LLM and the more tools you enable it to consume, then again, like with the data in its own internal training data set, the higher the probability that you may get a response that isn't appropriate or accurate and so on. If you tightly constrain the LLM to a certain small prompt with a small set of instructions and a small number of tools or functions that it can call, the more likely you're going to get an accurate response in that context. And if it can't handle that context, it just hands off to another agent, and that's pretty much what multi-agent systems are about. And then there's chain of thought reasoning, and there's a bunch of other patterns and techniques as well. I just picked what seemed to be, I think, the most popular. And at least these top four we'll cover in this one demo that I'm going to show. So hopefully that will uncover something. So I created a bit of a multi-agent sample with Spring AI. Spring AI itself doesn't give you a multi-agent orchestration framework like some other frameworks do, like LangChain and semantic kernel and so on. Rather, what it gives you is the building blocks to create your own, and that's exactly what I've done in this sample using Cosmos DB, as well as both the chat store and a transactional store and a vector store as well. So high level, how it works, you have a UI and a CLI kind of program that you can run as well, and a data loader that just loads some vector data and also some transactional data as well. Well, just a single record for the user. And then there's an API layer, a multi-agent controller. It's a Spring Boot application that will call a service layer that is consuming an agent orchestrator where we have agents loaded and defined that can do different tasks and so on. So the key class in this sample is going to be this thing called Agent Orchestrator. I stripped out some of the dependency injection stuff here, and pre-invocation logic and response wiring logic, because the main thing really where the magic is done is with the chat client that is an abstraction out of Spring AI that allows you to call a bunch of methods that are able to do some pretty cool stuff. And in this class, you can pretty much see all of these patterns in one place being implemented. Tool use, you can pass an array of tools. I'll show those later as I'm going through the sample. And in this case, I'm also passing in a tool that is able to do retrieval augmented generation, or RAG, and injected as a tool that one of the agents is able to call. Of course, passing in chat memory. In this case, it's what's known as long-term chat memory, because we're storing it in Cosmos DB, a database, so it can be kept there indefinitely and retrieved indefinitely at any point in time when the user wants to come back and carry on the conversation. And then, of course, the agent orchestrator is able to define specialized agents, register them with circumscribed prompts and different tools that it can call in each case, and then it can hand off and so on. How an agent is defined in this sample, pretty simple: an agent name, a prompt that is going to define what it can do, a list of tools that it can call, and a list of other agents that it can route to. And then this is how one agent might be defined using that record. And so you just got a prompt in there. And then in this case, it is able to do a product search, passing in a vector store object, which is abstracted in Spring AI and integrated with Cosmos DB. So just a little, just keep it really simple of how RAG works. I think you probably know by now if you've listened to that earlier session, but if you don't, there's no reason to overcomplicate it. A user question comes in the form of text. It's vectorized or turned into a numerical representation. That numeric is used to search against a preloaded vector store of data that you want to be searched, and a similarity algorithm, a mathematical similarity algorithm, whether it be cosine or Euclidean distance or whatever, is used to determine what vectors in your store are closest in mathematical distance to the input that you've provided, and then whatever comes out is rank ordered and passed into the chat completion API. In this case, it's OpenAI's chat completion API, and that is used to formulate a response. So like I said, you're spoon feeding the LLM instead of letting it direct the question to its massive internal training data set, you're saying, no, look at this, and we're just plugging in the logic to do the search and then passing in the output and along with the context and the question. So nothing complicated there. All right, so demo time. I did record a demo just in case everything goes wrong. So if this screws up, I'll default to that. So the entry point here is going to be this multi-agent controller, which defines an API that can be called, the most important of which is going to be this completion API. But before I go through that, I just want to show the config here. This is a Spring Boot application. As I said, there's a bunch of beans that I'm defining here. Now, if you were to go to the instructions on the Spring AI website of how to wire up the vector store for Cosmos DB, you'd find this, and it will be showing you to define a bean here with Cosmos client and everything here, and that's fine. But what I've done here actually is just define the Cosmos client bean separately, and the reason for that is, in this case, I'm using Cosmos DB both as a vector store and as a transactional store. So I've used Spring Data to define a bunch of entities here. And notice I've defined the product entity as an entity that is I'm using it in my transactional store, but it is also defined as my vector store up here. Where is it? Is it down here? Yeah. So what you'll find when you exploring different frameworks is many of them will assume that the and it's a transactional. So in this case, it's both a product catalog, because I want to check when I'm doing orders with my order item class here, I'm going to be checking against the product entity, whether that product exists, but also when my agent that is able to search for product information, I want it to also be able to search the product container for information and use vector search to be able to do that. So in my product catalog, I have information about the product, but I also have embedding of the product description, so that that can be used for vector search at the same time as well. So that's that. Notice, I mean, you heard about it before as well, but Spring AI has the same feature. Various methods have a tool decorator. Anything that you mark with having this tool annotation, that's signifying to Spring AI that I want to be able to, the LLM to be able to generate code dynamically that can call these methods. And then when you are defining your agents, which you in this sample we're doing in this multi-agent service, you'll see here in the prompts things like, yeah, then call order item tool passing user ID and item ID. If I haven't flagged it as a tool that can be called, then this wouldn't go anywhere. But because I have, then I can give a hint and say that this is what you want to do, and then it will do that and pass in those parameters and so on. So yeah, I think that's all I wanted to show. I mean, I'll just go quickly to the Cosmos account. I have the product here, and I just have one record in here for my user, and I have nothing in purchase history because it is going to do all of that for me. And the LLM is going to call various tools via the framework. It's going to hand off between different agents as well. Oh yeah, one thing I do want to mention as well, and this is a kind of like an example in real time, I guess, of this concept of trading off between actually hand cranking code and letting the LLM do everything. I think you heard a little bit mentioned about this or touched upon in the previous session about using an LLM for routing, either by tool calling or just by using the LLM to just determine which agent should be called next in the multi-agent scenario. Now, all of this logic here that you see before and after the call to chat client, I could have actually just used this agent routing sample and called that and let the LLM determine which agent to go to in every single turn in the conversation. But from my point of view, and at least from my observation, when things get complicated and if it's not so clear which agent should be routed to, sometimes that can go wrong and you can get into an infinite loop. So I thought, at least if I know which agent has responded to the last message, I want to deterministically route back to that agent, right? I don't want to rely on the LLM, because everything the LLM does is not deterministic. It's probability based, and it might not be predictable, and it might not be accurate. So I want to control that. So this is a case of where I'm, trading off on spending extra time writing code. And of course, what did I have to do? I had to create an agent transfer class. I had to define a bunch of tools that are going to be called by each agent to transfer between agents. And then when I know the agent, then I'm going to store the active agent in a chat session container within Cosmos DB, and then update that each time the agent changes. So when I know what the last agent was, I can route back deterministically to that agent without relying on the LLM to do that. And that's okay. And there may be other scenarios, is all I'm saying, where you want to do that because you see a certain behavior that in that context and in that scenario and in that use case, you want that to be deterministic. So you don't want to rely on the LLM for whatever reason. There you might hang crank what is happening. But I would say, as a general rule for building these kind of apps, start from the point of view of let's see what the LLM can do. Let's see how much it can do in this scenario with just some simple prompting, and then build around that is probably a decent rule of thumb to start with, at least. All right, enough talking. Well, I'm still going to be talking, but let's start actually demoing this thing. So I'm firing this thing up. Hopefully I don't get any issues. May the demo gods be with me also. Okay, looks like it started up fine. So let me go and find this here. And first of all, I'm just going to say, tell me about your smartphone products. And what I expected to be doing in the background is first, this because it's the first chat that I've done, it's going to be routing straight to the product agent. Yes, it has, and it's going to straight away do a vector search and come out with some results. You can see there the query happening. That's output from the vector search implementation behind the scenes in Spring AI. Didn't need to do anything except define the calls to it, and we see the code for that in here. I just passed in the vector store object. You can, the sample is publicly available on GitHub, by the way. So if anything you want to look into, we'll share the link at the end. Just calling similarity search is very simple, but it's a tool that the LLM has dynamically invoked as part of this process. So let me go back and see, okay, which one do I want? I want the LG phone. Transferred you to the sales agent to proceed with the ordering. So I need your user ID. So first, let's go and see my product purchase history. It hasn't done anything yet. User ID 1. Shall I go ahead? Yeah, I pretty much already said yes, but okay, non-deterministic. Your order has been successfully placed. Did it do it correctly? Let's see. And there we go. I changed my mind. To tell you what, I want a refund. A refund. Is it going to give me a refund straight away? Oh no, it's transferring me to the refunds agent. Yes, confirmed. There we go. And hopefully this should now say, yeah, date of refund. All right, and that's pretty much all I had to show on this one. I don't know how I'm doing for time, but I guess last thing that I promised was, there's the link. If you want to try the sample, definitely encourage contributions or questions about it. Only published a couple of days ago, so please try it out. I'm happy to take questions if we've got any time left.
Oh, thanks. Yeah, we do have a bit of time left, like a minute or something. So there is a question. If Cosmos DB is used for chat memory, can Azure OpenAI consult this rather than chat context having to be passed with each request, which of course increases the tokens consumed with each exchange? I'm not 100% sure what does this question mean. Like, do we have any secretly added Azure OpenAI, or what do you mean?
That's a really interesting question, actually. Couldn't OpenAI just do this automatically? Since OpenAI is already using Cosmos DB, it's a very good question. Maybe for the future. I think more where the question sounds like to me, more where the question is going is, isn't this just abstracted into some framework at least or somewhere? And the answer is yes, it could be, and in the future will be, at least for Spring AI and other frameworks like LangChain4j, will be embedding, baking this into those frameworks so that it's not something that you have to wire up yourself. It sounded like the question was asking also the overhead of having to call the service, the Cosmos DB service, when this is already the chat data that you consume in ChatGPT, for example, is already storing its data in Cosmos DB. It's an interesting question. It's maybe something we have to talk to our friends at OpenAI about as a possible enhancement there. But I would say Cosmos DB, like I said at the top there, it's very fast for atomic operations. You have guaranteed single-digit millisecond latencies on both reads and writes, which no other database in the world will guarantee. And that's all you're doing in these scenarios. You're storing and retrieving by partition key and ID value the chat items. So it's pretty fast. So not too much of an overhead, I don't think. There's always a trade-off with these things, but still, I think it's pretty rapid.
Well, are they asking if Azure OpenAI uses Cosmos DB in the background, so I can also use it like that and don't have to need to have another Azure Cosmos DB instance?
Yeah, I think it's another question angling at the same thing. If OpenAI is using Cosmos DB in the background, can't I just do all of this, get OpenAI to do it? Again, it may be something that is more tightly abstracted in the future with OpenAI or Azure OpenAI as a pane of glass. And actually, that is what the Azure AI folks are working on. And there is a service in Azure AI Foundry that actually does store this chat data in Cosmos DB, and this is all wired up automatically. So if you want to check that out, go and check out Azure AI Service, because all of that is being built as I speak. And like with everything, with Spring AI and every other abstraction known to man, there are trade-offs with having those, and having the control of controlling what the service is doing and what it's able to store allows you to bypass any restrictions that might be in those abstractions that are offered out of the box. So there'll always be a bit of a trade-off there, even when that is in place. But yes, the answer to the question is yes, and that's being worked on right now.
Okay, thanks, Theo. Also, thank you a lot for contributing to both Spring AI and LangChain4j. So we have the possibility of using Cosmos DB easily as our vector store here. And yeah, definitely check out his repository, because this guy knows what he's talking about, as you have heard in the last presentation. Thanks again for being with us.